All right, so I'm feeling kind of good. So I think I am going to do another one of these today. So because of that, I'm not going to call them days anymore. I will just call them streams because that is what they are. So if you look at this, this is what we did on stream 1. And just as a reminder, let me go to open up another one of these. Let me go here and open up another one of these. And I will just show you where we are going. So again, this is the game we will be working on, which is a Tetris clone that is written in Odin, and it uses the Raylib library. So that is what we are working towards. And for today, what we're going to do is mainly try to get tetraminos in some shape or form shown on the screen. But actually first, let me show you some debugging stuff. That would be nice to know. So first, I am going to open up this in VS Code because I know a lot of people use VS Code, so I want to show how to go about setting up debugging in that. So let's open with code and let's see what we get in here. License violation, please install. What? Oh, well, in any case, I am going to pull over some older stuff I have from another repository. So just bear with me here 1 second. Let's try this. So I'm going to make a folder called VS Code, and then I'm going to make a tasks and a launch JSON in here. Let me see if I could just drag these guys in here. So basically what I did was I set up a task.json file, and what that is some type of task or work that you can run, in this case, on the command line. So that is just running my build.bat script. And one thing that is important here that you will need to have is this debug flag, because that will make sure that there are symbols in the executable that you're building. So also, alongside a task.json, you'll need a launch.json that tells the VS Code debugger front end how exactly, like what executable to actually load. There is some other stuff here, like the current working directory, request is launch, and the symbol search path. And the type in our case is C++, Visual Studio, debug. I know we're not using C++, but you'll just have to trust me that that is the option you want to use there. So we're going to go here and run that and see what happens. Okay, awesome. So this is now building and running that Tetris code. And what I am going to do is I am going to go into my source, into my game, and then I am going to ignore these things. And I am going to put a breakpoint right, probably like here. So I'm going to press F9, I think. Yeah, okay. So this is going to set a breakpoint here. And then on the left side, we can see all the variables that are currently in scope, and we could press F10 to step over things. So now it's going to draw each of the rows. I'm going to hold F10 to keep going. And then after it draws all the rows, it's going to draw all the columns and whatnot. And this is very helpful that if you have a bug, you could come in here, put a breakpoint where you think there could be a problem, and inspect all the variables or step through the code to see what is actually getting executed. I'm going to press stop to stop that. And that, in a nutshell, is how you debug in Visual Studio Code, which a lot of people do. However, I don't use Visual Studio Code for debugging. I use a program called Remedy BG, and I am going to show you how you would set that up. Which you could also look up Remedy BG online. It is a paid debugger that you could find on itch. So I'm going to make a new session. I'm not going to save anything. So in this session, what I'm going to do is I'm going to select the command that we want to debug. So I'm going to search for Tetris edu, which is right here, and here is the application. The working directory for right now will be just Tetris edu, and I'm going to start debugging, and there we go. So open up a source file to actually step through some code. So I'm going to place a breakpoint right around here. And as you could see, this is just the same as Visual Studio Code in terms of the concept and the idea. I just find Remedy BG to be a bit more pleasant and speedy to work in. So that is why I use that. And I suppose I will show Rad Debugger as well, but it is a similar concept to Remedy BG and VS Code. Let me see, do I have? And here is Rad Debugger, which I haven't used in some time. It is in development by someone who works at Rad Game Tools, which is I believe, owned by Epic, the company that makes Unreal Engine and Fortnite and whatnot. And yeah, they're known to be a very good programmer. All right, so let's add a new target. I think that's what we want to do in here. And you could find this on GitHub. So Command-Shift-P, that'll open up this. So target, add target, yeah. And let's search for my Tetris edu and my Tetris exe in the working directory, yep. And let's run it. Okay, it's running. And same situation, I'm going to do, I think, Control O, and that should be able to open the file. Okay, there I go, and let me just put a breakpoint here, just like it did in all the other ones, and step through. And that is how you use those three debuggers. Rad Debugger is currently free, as is VS Code. Remedy is a paid one, but I highly recommend using one of those going forward in some capacity. I'm also just going to turn this, I'll put it like in a dark mode for now, I guess, because why not? I usually use dark mode when the sun starts to go down or it starts to get a little darker outside, and maybe that'll be easier on the eyes for switching back and forth between applications that are also in dark mode, but maybe I will switch back sometime. Only time will tell. Okay, so now that that's out of the way, let me go over this again. So yeah, we're gonna get some Tetramino stuff done. Let me just mark this that we did that. So the first thing I think I want to do is just have a block, like literally a singular block, like a tile that is moving around the screen that we could use our arrow keys to move around and maybe enter to place, and then we will get another block that we could work with. and then place that around the screen as a start. Okay. So what I think I want to do is block to place, and that will be set to the row and column type situation. So I'm just going to set it at 0, 0. Cool. And then what we're going to do is in here, we are going to, so if, well, actually, let's first draw it. Okay, that's exciting. Seeing things is always exciting. So let's go down here to where we draw the blocks. So we're drawing the blocks, and then we also want to draw the falling block / block to place. And what we want to do is this is the block, RL rectangle, and we're going to do a similar thing that we did here. So boom, boom. And then this will, this will be the block to place X, block to place Y. So if we build this, and why is that having issue? Is it because Tetris is running? Yes, it is. Let's do it again. And then after that, I'm going to go to Remedy and just give it a run. Okay, we don't see anything in the top left. We were expecting to see something there. And that is because all we do is actually make a block, but we didn't draw the block. So I'm also going to copy this here, paste that there, and let's make it a different color. Let's make it cyan. Oh, I guess they don't declare it cyan, so let's make it sky blue. All right, there we go. And if we place a red thing there and a red thing there, the red overwrites that. And I think just for now, not that it actually matters, but I am going to move this below this, just so it appears on top. And then what I'm going to do is make it so that if is key pressed, and we'll go up. So if it's up, then what we want to do is block to place, and then the Y will go -1. And actually really quick, so the way Raylib does its coordinate system, at least in the 2D mode, is that the screen starts at 0, 0, and you go positive in the X direction and positive in the Y direction downwards, where normally in math, you would expect the Y to go positive in the up direction. As far as Raylib is concerned, in this coordinate system, the Y goes positive, which is why you might see it sometimes like that. Some people will do things where they'll make it so that their game could use Y in the positive, because it kind of makes sense, because all math is in that. But I think for right now, we are just going to use this particular type of coordinate system. So I am going to do that for basically all the different directions. So down will be plus, left will be -X, and then we will do right, and that will be +1. We will build that. We have to close it out, do that, and there we go. And now you see I am able to move the block around the screen. And what we essentially want now, or at least what I think would be good to have for right now, keep saying what we want, but I don't know what you want. I only know what I want. Okay, And I'm also going to name this, oops, let me actually do this block to draw. Okay, there we go. Block to draw. So I want it so that you could actually place the block. And actually, one thing I want to see right here is, okay, so see how I could actually move the block outside of there? I want to prevent that from happening. So what I'm going to do is clamp the X, so block X equals, I believe that would be in the math library. Is I'm going to clamp it so that it stays in the tile map. So, or the play field, because this is not a tile map, this is a play field. So width, I think, this one, and then we'll do the same thing for the Y. Y equals height, undeclared name, block, okay, block to place. And what I'm doing there to select all those things at once is I'm pressing Control D to highlight the word, and then Control D to highlight the next. So that's what that was. Okay, so now I cannot move outside of the screen. So we have the tetramino moving around, or not the tetramino, it's just a block. And by the way, the reason it's called a tetramino is I think the tetra, or whatever, I think that means 4, because each tetramino has 4 blocks in it. Okay, so block to place, block to draw, and what we want to do is actually have something that we could place the block. So if RL is key pressed, and right now I'm just gonna do enter. What we then want to do is the play field state for block to place Y, block to place X. We want to set that to true. And then what I will just do right now is just set this back to 0, 0. Come in here and verify that that works. So we're going to come here, press enter, that's red. Press enter, enter, and enter. And beautiful, we have a tetramino-like shape going there. So now what we need to do is actually get some tetramino shape action going on here. So we have something going with these blocks right now. And what we more so want is actual tetramino shapes that move all together. So the first thing that kind of comes to mind is having some way to represent that shape. And there's 2 ways that come to mind right now. So we have a grid, right? And the way that we are representing tetramino's blocks in the grid is whether or not the row and column are set to true. So for instance, this would be 0, 1, 2, 3. So x3 and then 0, 1, 2, 3, 4, y4. And that this is set to true in here. This is row. This is column. But I like to use x and y. And this is, you know, the width by the height. And one way you could do this is, one second. So one way you can think about it is if we had like a smaller 2-dimensional array to only hold the Tetris on off, or the block on off data. So let's say we have a two-dimensional array that is 4 by 4, and for the L shape, let's just say that all these are true and all these are false. And that is a way to do it. Like, that is a way to hold that particular piece of information. Another way to do it is you can have like the idea of an L, and you could say, and because tetraminos are all 4 like long, so they're all 4 blocks, is what you can do is hold the position kind of index information locally to this thing. So you could say something like, this is 1, 0. The other block in there would be 1, 1. The other block in there would be 1, 2. And the other one would be 2, 2. So this one goes to this guy. This one would go to that guy. That one would go to that guy. This one, oops, messed up slightly. This one would still be, so 0, 1, 2, 3. So that would be a 1, that would be a 3, and then we would get a 3, 3. No, a 2, 3, sorry. So this would go to that one, and that would go to that one. Maybe I made a mistake in there somewhere with the math, but you get the idea of what that is trying to express, I think. 1, 2, 3, 4, 5. Oh, well, the mistake was that Ezra shouldn't be there, and it should just be that one. And this one goes here. Hopefully, you followed along with that, because I made a mistake. So I'm going to go with this particular representation for now. And the only reason is because that's sort of just what's coming to mind, I guess. So if we were just in this representation, it would be a bunch of true and falses, like false, true, false, false, for whatever particular shape, whatever dimensions of the two-dimensional array that we happened to pick. So in this situation, it's that. And in this situation, we hold the numbers information. And you very much well could go with this one. I am just happen to be going with this one, and maybe we'll find out that that's not like the best way to do it, but I think it should be a fine way to hold that information. Maybe. But like I said, maybe we will find out that that is not the best way. And then we'll learn the hard way. So what I am going to do is first get the O shape, because that is 4 blocks. Yeah, let's do that. So there's 4, and then int and in here what we're kind of going to say, so for the O, like let's just say 0, 0, 0, 1, 1, 0, and 1, 1. And I am going to actually draw it in the code sort of in the shape of the O. And you can see like what I mean, because the O is shaped like this. Oh, and by the way, this is called an O. This is called an I. This is called the J. This is called the L, the O, the S, the T, and the Z. Those are the names that they go by. All the different tetraminos, and those are the names that I will use. Okay, so that is the O. There's 4 blocks in there, and it's 2. So what I am going to do here is, this is the block to place. So let's call this instead tetramino pause to place. And then what we will do is, instead of just drawing that particular block, we will draw all of the blocks in the tetramino local to the playfield. So I'll show you what I mean. So for 0, or actually let's just say 4 block pause in O. Actually, let me name this tetramino O. So maybe it's a little better. So tetramino O. Okay. Tetramino O. And what we're going to do now is then come in here, in there, in there. Oops, you also want to get this rectangle in here. And this instead will be block pause in tetramino space. And then what we want to do is block pause in playfield space. And what that would be is the tetramino pause to place plus this one in the tetramino space. So remember that this one is relative in like the tetramino space. It's relative to the description, the idea of the tetramino. Like these are 0, 0, 0, 1, whatever. And a lot of them will look like that. But we want to find out, okay, well, now that it is moving and it sort of has a position in the space, we need to get the position of all the blocks in the playfield space. And Odin has the ability that you can add arrays of data together so long, yeah, you could add arrays of data together. So just this plus will do, because we want to take the position and add each of these to it. And hopefully you'll see what I mean. Hopefully there's nothing wrong there, and that everything will work just fine. Block to draw, playfield position, and let's build this and run it and hope. Okay, so now we have an O moving around. And notice how, like, when I place it now, it just places that, and also the O moves a little bit off the screen. So we're going to make it so when we place it, it places all of those things in the grid. And we also want to make it so that it can't exceed the bounds of the grid. So what we're going to do is we are going to say, so I'm going to do the bounds checking now. So for block pause, I'm going to loop over it again. And we want to get the block pause in playfield space. And we want, at least what I'm going to do right now. And sorry if I keep saying we want, because I'm just doing the first thing that comes to mind, is if this guy, the x is less than 0, if it somehow got less than 0, then we want to just move it back to 0. Let me just copy that. or actually what I should say is the Tetramino pause to place. Let's just keep doing this. I think this should be fine the way I'm doing it. Okay, so now we want to say if it's greater than the playfield width, and I think -1, greater than or equal to the playfield width, greater than playfield width -1. I think that would be like the last available index it could do. We want to set that to the playfield. So what we can actually do instead, because I guess what's happening is like the idea that we need to move the Tetramino pause to place back 1. So I'm just going to do a -=1 for now, and we'll see what happens. And let's set that to +=1. Again, I might be making a mistake here, but we'll find out. Do the height, and that will be y -=1. Then yeah, and then we'll do this one, and then make this the y. And let's see if that does anything reasonably fine. No, it does not. Because we want to actually check this block position, not the Tetramino position. Uh-oh, so now it don't even do nothing. Okay. This is the thing that you need to push back. Okay. So now we are unable to move outside of the grid. And it's probably a much better way to do that. This is just the way we're doing it now. Okay, so let's get rid of this clamping because we're doing it like that. And then what do we have? The place. So if the key pressed is entered, we don't just want to set the position to place. We actually want to set all of these. So let's do this. And then we will set this to true. Okay. Let me get rid of this stuff over here because that's basically useless for us right now. So we can see the whole thing. Let's run that, do it again, and let's see if we press enter. Yes. Okay, so now the entire Tetramino can get placed just fine. Okay. And I seem to be doing like this notion a lot, like looping over all the blocks in the Tetramino and then doing a transform to it. So we will likely want to have some type of function that does that particular thing just because we are doing it in a few places already. How much time are we at? Okay, we're at like 42 minutes. So we want more Tetramino shapes to work with initially. So what I am going to start to do is make some tetramino descriptions of all of them. And they'll have IDs. So I'm just going to do this. So tetramino. And this is just like the tetramino name. So I'm just going to make an enum of these and call them O, J, L, S, Z, and I. I don't think I'm missing any of them. And what we will want to do is tetramino shape description. So this is the description of the tetramino shape. And it is going to be an array of like tetraminos, like with the enum, those IDs. And it will be 2 ints each. Tetramino shape description. All right. So what I'm going to do is say O equals this guy. Nice. And then what I'm going to do is start writing them out for some of the other ones. So let's do the I. Okay, so now we have them all out. And you can see like why I wrote them like this, because I'm trying, I guess, to visualize what they look like. It's a little easier for me to see. And then what we will do is have an active tetramino of type tetramino, and we'll set it to O initially. And what we'll do is, instead of just using the O, what we will do, so I'll find everywhere I am referencing that tetramino O, and what we're going to do now is do the tetramino shape descriptions of the active tetramino, and I think that this should still work. So it still works. And now what I'm going to do is just change the active tetramino to maybe the S or something. I don't know. And now we have the S. So what I want to do is a way that we could cycle through all the different shapes. And I think the best way I could think of is hitting the letter on the keyboard that the tetramino corresponds with. So let's do that. So if RL is key pressed, and this will be O, do active tetramino equals O. Okay, easy enough. And we'll just do that a few times for each of them. So this will be I, this will be S, this will be Z, that will be L, and that will be J. I think that's all of them. So let's build that, run it, and then we come here. So the I switches it, the O switches it, the L, the J, the Z, the S. Hey, they all look fine and dandy, as far as I could tell. There you go, we have tetraminos moving around the screen just fine. And let's actually verify that it stops them from moving. So yes, it stops them from moving out of the screen. The only worry I could think of for right now is that if we change the active tetramino, oh no, it actually seems like it stops it from going out of the screen. So that's cool. Oh, okay. So the reason it stops it from going out of the screen is because it doesn't like do the collision sort of checking when you're moving it. It just does the collision checking no matter what. Like it'll just check if it's out of screen and then move it a certain thing. But I could see how there could be issue if, like, let's go here and like I could sort of almost see an issue if I guess there's actually not an issue. I thought there would be an issue because it's only moving them over one space. But the thing is if two blocks are out of the screen, it will do the -1 twice. So I guess like what I'm saying there is, say how we have it right now, that we have an O here, right? And we switch at that time to an I. So it's actually, there. So it's actually, okay, that's 2, and that's 2. So there's 2 in and 2 out because it's starting in the 0, 0. This was the 0, 0 right here for the position. And because this one gets detected that it's out of range, it's going to -1. So it's going to shift it over once. But it also detects that this one is out of range. So it's going to shift it over again. Oh wait, someone asked a question. I don't know when they asked it because I wasn't looking at it. Oops. Okay. So essentially what I was saying here is that it will get shifted over twice, how we have it, but I'm still dubious. Oh, those will actually like get moved over twice because it detects it was out of bounds 2 times. Now I'm still dubious of whether that will actually be good in the long run, but for right now it's actually serving our purposes. I don't know if that's the correct way to phrase that, but that's what's happening. So doom, doom, doop, doo. Okay, cool. So we got some tetraminos going. So we set up the different tetramino data. We can move tetraminos around the playfield, and we could place tetraminos around the playfield. Let's just verify that. So if I hit enter, that gets placed. If I hit enter, that gets placed. If I hit enter, okay, yeah, so we can now draw very comfortably with our tetraminos. And we're almost out of time for what I wanted to do. I only wanted to do about an hour right now. So I think what we want to do for stream 3, what we want to do, so I'm not sure if we want to do rotations. Well, let me just write things in the to-do. So rotations, and that would be implementing the super rotation system, which could be seen here in this page, actually. So what we could do is implement the rotation system. We could also, before that, probably do like collisions against the playfield blocks. Different colors for tetraminos, and that would kind of carry over in the playfield as well. So when we place them, it doesn't just turn to red, that it will hold whatever color data they have. So different colors for tetraminos, collisions against playfield blocks, rotations, a super rotation system, which we'll probably want to do after the collisions, I think. And then we will want to do falling tetraminos. So that means they fall, and when they collide, they will stick there. we want to do hard dropping, so that hard dropping and then ghost. I think the ghost would come before because you kind of use the ghost to determine where the hard drop will go. And what I mean by ghost is you can kind of see it here. So like if there's a blue tetramino up here, that if this was the ground where he would land, so if this stuff wasn't here, it would display where your piece is going to fall before it falls. And you can kind of use that data for the hard drop, which is like forcing the piece to immediately go down. So we want to do ghost, hard drop. And that's what I could think for right now. And we'll just add more stuff to the list as we need it. So I think one other thing is like we'll make playfield bigger than the visual, like make actual / logical, it would just be the actual, bigger than the visual playfield. So playfield is larger than what you can see because tetraminos fall from above and could actually get placed in spaces you can't see. And also once we implement garbage in 2-player mode, that will want to make sure there's enough buffer room in the playfield that it won't go out of bounds or anything like that. And we'll implement some more API stuff for the playfield as well, so that we're not directly accessing the data in the two-dimensional array. So that is some stuff we'll work on. And thank you for watching. Appreciate it.